Hi everyone, I'm back with another easy question from Pathfinder Thermal Physics. It states that two cylinder A and B of equal volume V0 contains the same ideal monoatomic gas at the same temperature T0 but at different pressure 2P0 and P0 respectively. They are connected by a thin tube installed with a valve that is initially closed. The valve is opened, and as the gas leaks from cylinder A to cylinder B, the pressure in cylinder A is maintained to P0 by pushing the piston into the cylinder. The process is continued until the pressure in the cylinder B also becomes P0. Find the final temperature in terms of T0 and final volume of the gas in cylinder A in terms of V0. Both these cylinders are in good thermal contact. Neglect heat loss to the surroundings. Okay, so it is said that both initially having um, same volume, same temperature, but there is a difference in pressure where the container A has 2P0 and B has P0, right? So then what happens is that um, the valve is this valve is opened, and um, as A has more pressure, which is 2P0 than B, so the gas will move from higher pressure region to lower pressure region, which will like increase the mole of B, and it will decrease the mole of A, right? So it is said that to maintain the pressure, the external force is given to the piston so that the volume is decreases and the pressure is maintained. Okay, the same pressure is maintained. So yeah, it is um, easy. Give it a try and then come to my solution. If you got the solution, then also I would request you to see the video, because it would help you to see that my solution and your solution are same or different, or yes. So yeah, going into my solution, it is given that the it is given a force. Let's say in this situation an equilibrium is established. Okay, so the pressure is maintained 2P0, and for B it is 2P0, right? So let's say that the volume of a container A, it is V at the equilibrium instant, and B volume is same. Okay, and it is said in the question that both the cylinder are in a good thermal contact. This gives that good thermal contact means the temperature distribution is uniform, right? Means um, if this temperature increases by like delta T, it is spread uniformly. So finally, if the temperature is T for a container, it will be equal temperature for the container B, right, which is T. So we can say that when the valve is open, the moles are spread to the container B, but the total moles is conserved for the system A plus B, right? Individually container, the moles are not conserved, but there's a total is conserved. So we use the conservation of mole. So find the total final initial mole is equal to total final mole. So we use this and we name it as equation 1, and we use a good um, um, equation, which is the first law of thermodynamics for the system A plus B, where delta U equal to W plus delta Q. Okay, this W is the work done by the external agent on the system, right? So using the first law of thermodynamics, delta u equal to W plus delta q. As we know that there is no external heat transfer to the system, delta q will be 0 and delta u equal to W. Okay, so we know that delta u equal to n in n cv delta t. So n is this the total moles, cv for monatomic gas will be 3r by 2, and delta t means the the temperature difference, where as initial temperature is T naught for both the system, and then it is um, T. Okay, so T minus T naught and work done by the external force. Okay, what is the external force? External force is that we're pushing it, means the what is the external force side? So this is the piston. Okay, so work done by external force. So in the equilibrium condition, the gases in the container A will give a pressure which is 2 a force 2p naught into A, where A is the area. So and the equal amount of force will given by the external agent. Okay, so the pressure, so it will be P into A. So the pressure, it is P equal to 2p naught. So work done by the external agent will be pressure into delta V, right? So pressure, it is 2p naught into delta V. It is initially it was V naught and then it is V. So V naught minus V is the work done by the external force. Okay, we got that V equal to 7 by 10 into V naught and T equal to 17 by 15 into T naught. Okay, so yeah.